Okay, Bismillahirrahmanirrahim. Um, we have to try some questions from past papers to see that if we are able to solve these problems on circle properties. Okay, whenever you have a question on these circle properties, you have to ask yourself, Malaika, that okay, if there are any equal angles, okay, if there are any right angles, if there are any supplementary angles, if any angle is twice the other angle, that is a key in your mind. Okay, equal angles, supplementary angles, right angles, and one angle is being double the other angle. Now, equal angles, when you have equal angles, this is something like angles in the same segment, or maybe you can have alternate angles. You might have an isosceles triangle. Okay, for the right angle, they are mainly like the angle subtended by the diameter, or if there is an angle between the radius and the tangents. So that is where you have the right angle. Now the supplementary thing, that is the angles of a cyclic quadrilateral, maybe angles in opposite segments, or if you have parallel lines, you have angles between the parallel lines. Okay, and this is clearly the angle at the center is twice the angle at the circumference. Okay, now I have to find this xyz. So I, rather than directly looking for xyz, I'll start playing with this. Okay, now I see that my first, this is my uh, this came in my side. First of all, this ce, so I'm going to say that this is going to be x over here, because you see, if you have a chord like this, look at this chord CE over here. Okay, so if CE is making an angle like this over here, so this would be the same angle over here as well. So if this angle is x, I can write this angle as x, because that is the angles in the same segment. Okay, and then um yes, oh, I have spotted um that cyclic quadrilateral as well. Look at this E, D, C, and B. Isn't it this B, C, D, E? That is a cyclic quadrilateral. B, C, D, and E. All these 4 points on the on the circumference. Okay, so this X and this 127. These are two opposite angles of this cyclic quadrilateral. Okay, so I got this X. X is simply going to be like these two are supplementary angles. So your X is 180 minus 127. I think that is going to be 53 degrees. Your X is 53 degrees. Okay. Now the next thing is, if you look at this, yeah, these parallel lines. Oh yes, I spotted the parallel lines here. Can I say that this angle over here, this angle in red over here, is going to be same as this angle over here? Because when you have two lines like this parallel, okay, and you have a line like this, so these two angles, they are going to be equal. These are the alternate angles here. Okay, so you have this z plus 40, this z plus 40 degrees, that is equal to 62. So I get this z as 22 degrees. Okay, then I am left with this angle y. Okay, angle y. uh if I look at this, it says the circle AB is parallel to ED, angle y. I have to find the angle y. Let's see. So angle y, I think if you look at this BC, this BC has subtended the angle A, I mean angle y at the point A. Can I say this is the angle y here as well? Yes. Hmm? Look at this BC. From this BC, you have this angle over here. Okay. And from the same BC, from the same chord, you have the angle here as well. Okay. So that means your y is simply going to be equal to 40 degrees. So we have applied three properties here. For the angle x, we have used the cyclic quadrilateral. Okay. And for the angle Y, we have used the angles in the same segment, which are equal. Okay, angles in the same segment. And for this angle Z, we have used the parallel lines, the alternate angles on parallel lines, alternate angles. Okay, so you have to remember all these things while responding to these questions. Okay. It looks, this is from winter 17, paper 22. This looks really an interesting question here. It says the diagram shows two circles, each with center O, A, B, C, and D are points of the circumference of the large circle. E, F, G are points on the circumference of the small circle. C, G, D, and C, F, B are tangents to the same, to the small circle. Okay, yes. So they are tangents, and lines A, E, O, C, and F, G intersect at 90 degrees at X. Okay. Now, Malaika, this point over here, that is going to make all our working easier. You see, the first property of the circle is that, um, uh, if you remember that, let me make you recall that, like if there is a chord here, okay, and if you draw the perpendicular from the center, yes, do you remember? Then this is bisection.
Yeah.
Yes. And then this is also an isosceles triangle over here. Now that is the key for us. Look at this. It says they intersect at 90 degrees at X. So if I mark this as right angle over here, everything is going to be clear now. If this is a right angle, this is already the radius. This is the radius. Okay. Then you can allow me to write like this side is equal to this side. Okay, if this is the angle Y, then this is going to be angle Y as well. Okay. And then it says they are the tangents. Look at this. They're the tangents over here. Okay. Now, since this is the radius, then this, all of this is going to be a right angle over here because the radius is perpendicular to the tangent. There is going to be a right angle over here because this is the radius and this one is the tangent. Okay. Now it says find the angle GEO. The angle GEO. This is the angle GEO. Okay. Now, do you remember angle at the center is twice the angle at the circumference? Now, if you have 2y over here, okay, or let's say if you have y over here, then this angle over here would be half y. So if this is 2y, then this angle is going to be y at the circumference, okay? Now, look at this angle GOF, GOF. That is just um, 2y. Okay, so all of this angle is going to be y, and since we are looking for this angle, so this angle will be half y. Did you understand this? The angle GEO, why it is half y? Yes, Malaika. Like if I just draw a line of symmetry through this, so you will be left with a half y over here. Okay, so that is how this GEO is going to be half. Okay, next you have to find the angle GCX. GCX. Okay, now look at this triangle here, like this. Okay, now this is your O, this is your G, there is a right angle here, and this is your C. This angle is Y. Can I say this angle over here is 90 minus Y? Because this is already 90, so the sum of these two angles is going to be 90 as well. So if this is Y, this is going to be 90 minus Y. This angle over here is going to be 90 minus Y. That is what he's asking. That what is this angle? Okay, so this is going to be 90 minus Y. Now, please confirm this if you got it or not. That is your 90
Yeah.
minus. Okay. Now the last part, I'll have to scroll this up. Uh, if I just scroll this up a minute, we have to find the angle DAB. Okay, the angle DAB. Yes, the angle DAB. DAB. Okay, the angle DAB. Yes. Uh, what do you think, Malaika? What should be this angle here? What do you think about this angle? What is this angle here? Hmm?
Uh,
Yes. Angle
it's
subtended by the
parallel.
diameter. Angle subtended by the diameter. If you have a diameter here in the middle, okay, so this angle over here, angle subtended by the diameter is always a right angle on either side of this diameter, okay. So this AOC is the diameter. Can I say this is the right angle here? Yes, this one is a right angle. Hmm? Yes.
Yeah.
Anna? And if this is the right angle, look at the whole bigger triangle ADC, the triangle ADC. So if this is 90 minus y, you can let me write this as y, okay? Because when one angle is y, the other is 90 minus y, provided one of these angles is a right angle here. Then if you have to find the angle DAB, since this is the line of symmetry going on, because of this is the key, this is telling us this is the line of symmetry, okay? So this is going to be Y as well. So this angle DAB is going to be 2Y. This was a very interesting question. Its next part is related to the congruency, so I'm not going to do that part, okay? If you have done the congruency, only then I can try that. What do you say? Should we move on to the next question?
What?
Should we move on?
Uh, what reason do we have to give for the answers?
Come on. For this angle GEO, this angle G, where was G? And there is E and this O over here, okay? You have to first of all show that there is a right angle over here, okay? So you have to tell the examiner that the angle, as I have done it here, you can give all these reasons that a perpendicular from the center bisects the chord. So that is also the line of symmetry like this, okay? So you can tell this is the line of symmetry, okay? And then you can say that, okay, look, um, this chord over here, if since this is the line of symmetry, so this angle GOF, you can say that angle GOF is equal to 2y. Therefore, angle GEF, the angle GEF, that would be y. And the reason is angle at the center is twice the angle at the circumference. Okay, you will write that. Okay, so once you have shown that the angle GEF is y, therefore the angle GEO will just be half y. That is half of that. Got it? And for the next one, which angle we found of, yeah, this one. For this angle, you have to start by saying that OG is perpendicular to this GC because radius is perpendicular to the tangent. And then you can show this triangle. I think I haven't giving all the reasons. You can just go back and see all these reasons here. Okay. I didn't write them because I didn't have space for writing it. Okay, so you can give, like, for example, why did I say that this is a right angle? I have shown you the reason here because angle subtended by the diameter is a right angle. You had this angle here, you could simply find this. And since iske andar jo, I mean, the most important thing is that is derived from this thing over here, that this CXOEA, that is a line of symmetry for this whole diagram. Okay, let's try some more questions. Okay, we have another very interesting question over here. This is from Winter 16, paper 12, and question number 24. Paper 1 question here. Okay, again, whenever you have questions on I mean, the angles, you must have in your mind that, okay, if there is there if there's any right angle over here, okay, if there are any supplementary angles over here, okay, if there are any equal angles over here. Okay, right angles are like, in a circle we have right angles if the angle is subtended by the diameter. You see, we have a diameter over here. This BOE is the diameter. Okay, so can I say that this is a right angle over here? This BAE is a right angle? Yes. Hmm?
Yeah.
Yes, right angle. So we can simply find this t by saying, okay, this t is going to be 56. Okay, this angle t is 56 degrees. Okay, so we got a right angle and then we got it. Okay, then do we have any equal angles over here? Angles subtended by same chord. Look at this.
Yeah.
If you
BD
look
will
at
be
this,
34.
if you look at this BD, BD is subtending the angle at A, and the same BD is subtending the angle at E. So your Z is absolutely going to be 34 degrees over here. Okay. So this Z is 34 degrees. Then look at the supplementary angles. We have supplementary angles in circles if we have the quadrilaterals. So we have quite a few quadrilaterals here. Look at this A, B, C, D is a cyclic quadrilateral, okay? So you can find this Y through this, its opposite angle, 34. They are going to add up to 180, yes? So this angle Y is going to be 146 degrees, yes? Hmm? And then we also have
Yeah.
this other thing, when one angle is twice twice of another angle. Okay, so you see that this BD is making an angle at the center, which is X, and the same BD is making an angle over here, or maybe over here, which is 34. So if this is 34, what do you think? What should be this angle X then? Hmm? This angle X is twice that 34. That is going to be 68. An angle at the center is twice the angle at the circumference. So this was a rather easier question. Okay. So that's it from today. We will continue these circles problem maybe in the next two more sessions. Okay. Thank you.